Hello, welcome back. Today let's try to solve another Leetcode problem, 774. Minimize max distance to gas station. So basically we are giving a stations array, so inside it is the stations. And we can also use the stations to calculate the distance. So the stations is in increasing order. So here it said it's sorted in a strictly increasing order. Yeah, if it is not strictly increasing, it means some of the stations will be overlap, but it's not that case. So this means our calculations would be easier. Otherwise, if there's zeros, it is not good for our calculation. And yeah, we are giving the integer array stations that represent the places of the gas stations or the x-axis, and we are also giving an integer k. So we should add k new gas stations. You can add the stations anywhere on the x-axis, but where should we insert the stations? So greedily, we need to insert between the middle of the two stations. For example, this is the 3 and 4. We should put another station at 3.5. Yeah, and 4 and 5, we should put another gas station at 4.5. Yeah, you should add k new gas station. You can add the stations anywhere and not necessarily or at integer position. This means we can insert at not integer position, for example 4.5. And we also have a penalty. So this penalty be the maximum distance between gas stations after adding the k new stations. This means, for example, for this example, we have 10 stations from 1 to 10, and we also have k new stations. So these 9 stations will be inserted into the stations between of them, between 1 and 2, between 2 and 3. We would insert into the middle of them. Yeah. So return the smallest possible value penalty within 10 to the power of minus 6 of the actual answer will be accepted. So this means it's an approximation problem. Normally we can also use a binary search to solve the approximation problem. It's also a guess problem. We just need to guess this value. Yeah, for example, here is a 0.5. So this means we're gonna insert the stations just between 1 and 2 and between 2 and 3. Yeah, we just need to understand this penalty be the maximum distance between adjacent gas stations. If we insert a 1.5, what is the maximum distance between 1 and 1.5, 2 and 1.5? Of course, it is a 0.5. This is why we're going to return 0.5. Yeah, and maybe you think, maybe we have a bigger value for example, why not 0.6? Maybe we insert at the 1.4 places. Yeah, let's check is that possible. If we insert at 1.4, so the maximum value between 2 and 1.4 is 0.6. But we need to return the smallest possible value. Yeah. So here, the biggest value is 0.6. Yeah. Now the smallest value may be 0.6, but it's not the smallest. Only if we insert into the middle of 1 and 2, then we have the smallest possible value of penalty. Because the penalty is the maximum distance. So this is a minimax problem. It's a typical minimax. You can see that minimax minimize max distance. And it's also a approximation problem. Now we can use a binary search to solve it because we can use binary search to guess this number. If it is smaller or bigger, we can use a binary search to search another. Yeah, if it is smaller, we're gonna search a bigger number. If it is bigger, we're gonna search a smaller number. Now let me go to the function and explain it while I am writing the code. Basically, for this binary search function, we're gonna use a tag. Inside, it will be a threshold. It will be divided as this number we guessed. For example, here the 0.5, we're gonna guess this 0.5. Before I'm writing the main binary search, I'm gonna use a pass for the tag. Then I'm going to write the binary search. For this binary search, we're just gonna insert the numbers between this like 1 and 2, 2 and 3. So this means we just need to get a distance array for the stations. If we can write a distance array, so the dist should be equal to stations from the second station I minus the first station, stations I minus 1 for I in range len stations. Yeah, so for here we got a distance array. Basically it's the second number minus the first number, and it's also a positive distance. Now we can use this distance array to guess, to check if it is possible to insert numbers. When we insert numbers inside, basically we can use division. Yeah, use this distance divided by a number to check, because this is a greedy way to check how many, this k, how many numbers we can get, if it is more than 9, more than this k, or less than this k. Now let's write the binary search function first. So for me, normally I'll use L and R pointer and a result. So the L pointer should be started from 0, because this is number is not integer anymore. It may have a float numbers. So I will start from 0, and the maximum number should be the max of the distance. So this means when we have a distance like here or here, we have a distance. So this means our guess, the maximum can be the maximum distance. It means we don't need to insert any numbers. So this is the max. This is the R pointer. It should be the maximum of distance if we don't insert any numbers. So here, actually k is more than or equal to 1. And we need to insert at least one station, but this is okay. Let's just guess k equal to 0. We don't need to insert, so the maximum, should be the max distance, and the result would be 0. Now I'm going to use the binary search. As this is an approximation problem, we should use the binary search r minus l less than and equal to 10 to the power of minus 6. So here should be more than, should be, while it is more than, let's put a more than. Because if it is less than or equal to, we're gonna return our result. Here it is said, the possible penalty within 10 to the power of minus 6. So for our answers, it should be within. So here, for the while, we need to check if this is more than, it is okay. If it is, let me check, it should be less than and equal to, should be within. So the binary search should be less than, should be more than this number. If it is less than, we're gonna return our result. So I think more than and equal should also be accepted. Let's put more than this number. It means if our guess for the approximation is to the 10 to the power of 6, it basically will not influence our result. So here we will put more than this number. Because if the number is too small, basically it is okay. We're just gonna have our result. Now let's finish the template function. So for the m, it should be L plus R minus L divided by 2. here we only need one forward slash because it's a floating number, it's not integer anymore. Now we're gonna check if this m is okay. Our result should equal to m, and the r pointer should equal to m. So this means if our guessed number is too big, for example, if here it is a 0.5, what about if this value is 1? Yeah, if it is a 1, how many numbers we need to insert? We need to insert like 9 numbers. Yeah, but here the distance is 1. We even don't need to insert, already meet the condition. If we insert at any place, maybe at the integer place, it is still okay. So this is why the r should equal to m. It means we don't even to insert any stations, it already meets the condition. Now let's just insert. If we don't insert, it already meets the condition. Then after insert, we can always meet the conditions. So this is why r should equal to m. Else, the L pointer should equal to m. Because this is approximation, the r pointer and L pointer should always be m. It is not m minus 1 or m plus 1. Otherwise, it is an integer. It's not our result because this is an approximation problem. Now, after that, we're gonna return the result. So here is for check function. The check function just gonna check if we meet the conditions. So basically, I'm going to define a count as my counter from 0. Then I'm going to loop through the distance array for d in dist. So the count should plus equal to. So here, I'm going to use some mathematical tricks. The integer. This integer will be the distance divided by threshold. So why this works? Let's guess if our number is 0.51. If it is 0.51, so d is 1 because d is a distance array. 1 divided by 0.51, it is 1.999. And integer after int, it is 1. So the count plus 1, it is 1. So after looping through the array, I got a count of 9. It means I meet the conditions. Yeah. So this is why I will use some trick as integer, because my final result would be the count less than and equal to k. Let's check another number. If our threshold is 2, for example here, the threshold is 2, and d is 1, 1 divided by 2, so yeah, it means not possible, because the max distance is 1. Let's guess another number, maybe 0.9. Yeah, it is still the same. Let's guess another smaller number, maybe 0.4. So for the 0.4, the d1 divided by 0.4, what's the number? Maybe, yeah, 0.4, it is 2.5, and the int, it is 2. Yeah, so for each time, the count will plus 2. So in total, it will be 18. So this 18 means it's more than this k, more than 9. It means, yeah, the distance is too small because we need to insert 18 stations to meet the condition, but we need to insert 9. It means it's not possible. So this means why we're gonna return a false for 0.4. What we should do, we just need to increase the L pointers to m. Now let me run it to check if it really works. Now let's check what kind of bugs do we have. There are some bugs. Output is 0.0, but we need a 0.5. Now let me check it. The L pointer, R pointer, and dist. Let's check the absolute value of R minus L. It should be always result. And now let me print out the list and print out the count. Yeah, here the distance array is wrong. So it means here we should start from 1 to length of distance. Yeah, this is something wrong because I started from the distance I. This for here I means I will start from the second index 1. It's not 0. Now let me run it to check if it really works. Yeah, as you can see, it works. Now let me delete the print and check my final result. At the same time, I'm going to print out the code because I'm going to use this code to show you how the number changes for each time of the function call of check. Yeah, here. Now let me run it first. As you can see, it passed 100%. It means it is okay. Now let's just check how the number changes for each time. And here, this is our code. So for the code, it is okay. And now we should check another threshold because basically we are using the threshold to guess. Yeah, let's check the threshold. So this is the code, and now let's check the threshold. As you can see, the code it is always 9, 18 to 9, and to 9. Yeah, but we are concerning more about this threshold. Let's check what is the values changes for the threshold. As you can see, first time it is 0.5. It means this number is too small. Why? Because for 0.5 d divided by 0.5 it is 2. And our final result is 18. If you check the count earlier, it is 18. It means too big. It is false. So for the next time, we're gonna check a mid number. It is 0.7. Yeah, and 0.75, it is okay, but it is still too big. So we're gonna approximate it to smaller, divided by 2, divided by 2, to smaller, until after how many function calls, as you can see it, not so many function calls, we've already got our result. So from here, the L minus the R absolute of R minus L is less than or equal to 10 to the power of minus 6. This means we're gonna return our functions. Yeah. So basically, this is the entire function, and the time complexity is m times log n. So the m is the length of the array list, and n is the numbers between the approximation numbers. So for here we have the L and R, but how many function calls? It's still not a big number. For this 10 to the power of minus 6, actually it's not a big number. It's similar to the log 10 to the power of 6, so it's not a big number. And thank you for watching. Basically, that's the entire code. If you think this is helpful, please like and subscribe. I will upload more Leetcode problem like this. See you next time.